Okay, good afternoon, sir. So right now I will be doing my poster. I'll be explaining parts of my poster. So I'm using a video to show that I'm the one doing the poster. I did the poster and I'll be the one explaining the poster for my voice and my face recognition. So after a few minutes, I will be moving it to a full view to let you get a better look on the poster. Okay, so let me start off with the objective. So the objective of this IPR, right, is to create a hardware device which enable music to be transmitted through LED lights, white LED lights to be exact. Okay, so the volume of the volume of the music is independent on the distance between the solar panel, which is the receiver, to the LED light. So let me explain briefly on this. So if the solar panel is near the LED light, the sound will be louder. So if the solar panel is further away from the LED light, the sound will be softer. Okay, so the hardware should be able to have play next button and a play/pause button, which their function is already play next or play/pause button. Okay, thank you. So let us get into the full view of the video and to let you get a better look on the poster. Thank you. Okay, so my main features, I'll be using Arduino Mega 2560 solar panel, push buttons, SD card module, SD card as well, PAM8403, which is a 3-watt audio amplifier, a JBL speaker, and 2 white LEDs. So let us have a closer look on the flowchart. Okay, so basically we'll have a start, which means I connected the Arduino to my 5-volt. So they will display press to begin. So the moment I press my next button, which is yes, you will go to the playing. So my LCD will display playing the song music, the song name, and my speaker will also be playing. So after that, if I press pause, yes, then the song will be paused. So if I never press pause, the song will still keep going on. So once a next button is being pushed, you will go to playing. The LCD display will display playing song number 2, and the speaker output will have the sound of the second song. Okay, so this is my Gantt chart. Okay, this is task of what I've done, the date and the completion date. So I've done the Gantt chart. So before a box up, so this is how it looks, the prototype before box up. The wire is kind of messy. So basically this is my block diagram. Power supply and music will be going with my SD card. My SD card will be holding the music to the Arduino. So LCD display, LED will transmit data wireless to the receiver, which is my solar panel, to the speaker. Okay, so this is my schematic, my hardware prototype, which will be shown more in the final video. So basically this project, the problems I encountered, right? So firstly, after I soldered everything, the LED light is unable to transmit the music to the solar panel, which results in no sound output. So with no sound output, actually this project is a total fail. So I tried to figure it out and I realized that the music was not in the correct properties to match with the audio amplifier so that it can be transmitted. Okay, so push buttons are unable to work as expected. So basically, let me explain a little bit. When I press the push button, I use the serial monitor to visualize, and actually it trigger a lot of time, which means a lot of times, even though I press one time, but the system captured a lot of time, so I add a delay. So once the delay is added, the problem was being solved. So components was not soldered properly, I bought a new one and resoldered it and it was fine. So I have proposal to improve. So actually we can add a touchscreen instead of LCD, which will enable music selection, which is much better, which people can get to select the music they want. So actually by adding a temperature sensor, you can turn it into a fire alarm, whereby the LED will turn on once the sensor hit certain temperature. So using fiber cable will also be visible. It will also be workable once you connect the LED to the solar panel, whereby fiber cable actually they transmit VLC, so they are made of glass. So lesson learned, I am able to understand how to write and read Arduino coding, knowing how to troubleshoot step by step to find the root cause, using online application to do the schematic, and understanding the importance of the flowchart for troubleshooting is very important. So the conclusion, I am glad that I am able to make the project work as expected with research and study, hoping that someone would do the same project as me and hence upgrade it into something useful in the market where everybody can use it. Okay, that's the end. Thank you. Good afternoon, sir. My name is Jeremy, and the purpose of making this video is for my final demonstration for my IPR, which is my individual project realization. So in my IPR, I'll be doing Li-Fi audio player with solar panel as a receiver. So Li-Fi, so what is Li-Fi? Li-Fi is a light fidelity, and it uses light to transmit data. Okay, so right now let me show you my circuit board, my box up, and a few of our components, and let me explain on how it works. Okay. So this is my box up. I have a SD card module with a SD card inside. This is my Arduino breadboard for my ground and my VCC. This is my PAM8403. It's a 3-watt audio amplifier. My LCD, 2 buttons. This is my play and pause. This is my play next, and this is my play and pause button. LEDs, 2 LEDs, white LEDs for transmission. My receiver, solar panel, connected to a AUX cable, then to a JBL speaker. Okay, so let me briefly explain to you how the components work and what is their functions. Okay, so basically the SD card module is for me to communicate with my Arduino for my coding to run the musics. So my SD card will have musics inside, which my SD card module will be connected to my Arduino. Then they will be transmitted out from Arduino to my PAM8403 audio amplifier, 3-watt amplifier, which will provide a low pass filter, which will provide a better sound quality, which is then connected to the LEDs straight away, which will be transmitting the song in a wave format to the solar panel, so that the solar panel is able to receive and then hence play the music in the speaker. Okay, so my LCD, the function of my LCD is to show the function. So for example, right now it's showing press, I don't know if you can see, press to begin. So when I press my next button, it will be showing the songs that it will be playing. So if I press my play / pause button, it will be under play / pause. Okay, so right now let me demonstrate my project. Okay, so when I press the next button, as you can see, it will be showing play. So when I put the LED near the solar panel, okay, so here's how it works. So when I press pause, it will be paused. So when I press it again, the song will be back. So when I play the play next button, okay, the song will come back. So normally the volume, it can be determined by the speaker itself, or you can either move the LED further from the solar panel, which will get softer and softer. Yeah, so if I move it closer, it will get louder and louder. Okay, so if there is no light providing to the solar panel, let's see if the sound also work. See if I block it, there will be no sound. The speaker will play no sound. So if I remove it, yeah. So that is about it for my IPR project. So right now let me talk about the Li-Fi advantages over Wi-Fi. So basically, Li-Fi it uses VLC, which means visible light communication, and Wi-Fi uses radio spectrum to transmit. So basically, visible light communication, they cannot pass through walls, unlike radio frequency. So basically, for example, in hospitals, in some of the normally in intensive care unit, they don't allow people to use their phones there because of the radio frequency that can interfere with the medical equipment. So basically, if we were to implement Li-Fi in hospital, there won't be this problem because Li-Fi doesn't pass through walls and it doesn't interfere with the hospital equipment in the hospitals. So basically, there are quite a few advantages of Li-Fi. One, which is actually in other countries, scientists has already proven that Li-Fi transmit data a lot way faster than like Wi-Fi, and it is cheaper than Wi-Fi, and it doesn't require a modem to work. They just need a receiver. Yeah. So basically, Li-Fi can be implemented in many places because basically actually everywhere in the world there are LEDs installed everywhere, even in the roads, in the library, in the gym, in everywhere in the world. Actually, that's why they will be easy to implement. But one issue is, if there's no light, how do we ensure that the data is still being transmitted, which I can suggest of using infrared. Yeah. So basically, this is all about Li-Fi, and this is my RPR. Thank you.